as corresponding to this EMA subject, and that too you are for you entered for mechanical branch. I wanted you to tell more about the concepts what you are going to learn in the higher semesters and the concepts what right now you are studying, all those things more than the syllabus. So I will cover more in the class, but as for the point of examination, you can refer the notes. Is that okay? Okay. I'll share the screen now. Just anyone can refresh what exactly it is done for the freshers other than the syllabus. Yesterday only I started the syllabus to discuss about the syllabus and content what is there in the syllabus. From yesterday only I started, right? Those who attended earlier, they'll be knowing. So can anyone tell what exactly we discussed? We discussed about
So different forms of energy, machines.
very good. Different sources of energies. Before that, I explained about what do you mean by the machine and what do you mean by how the machines are classified.
Power generating machine and
power consuming machine.
Very good. Power generating machine and power consuming machine. Those who joined today, okay, you can refer the yesterday's class that I shared in the Google Classroom. Google Classroom code I will share once again in the WhatsApp group. You can join, all of you can join to the Google Classroom. There I have shared all the class videos. You can refer the class video. If you have any doubts, you can contact me. Okay. And yesterday only we entered for the discussion of the within the syllabus. What is there in the syllabus? How exactly we are going to flow? What is the content and all? We discussed earlier. And from yesterday, I went into the syllabus. There we studied about what do you mean by a machine. Thoroughly I think probably I taken more than half an hour to discuss about the machine, how it is classified. Can you see the screen? No?
Yes, sir.
Okay. And we discussed about how the machines are classified, and where the engine will come into picture, where the turbines will come into picture, where pumps are coming into picture, fans, room heaters, grinders, mixer, washing machine, all those things where they are going to fit. You should be thorough enough to understand. Okay. Washing machine, can anyone tell washing machine where it will fit? Whether it is a power absorbing machine or whether it is a power generating machine or power consuming machine?
So power consuming.
power consuming.
Very good. Power consuming machine. It is going to take the electricity, and what is the desired work from the washing machine? What is the desired work from the washing machine? The desired work from the washing machine is to wash your clothes, right? Like that, grinder, mixer, room heater. You take n number of examples. Any device which takes the electricity and do a desired work for you, then we are going to call those machines are power absorbing machines. And any device taking various sources of energies and producing electricity are considered as power developing machines. Example for those are, yeah.
So what about power banks, like the phone charging power banks?
They are neither power producing, neither power transferring. They are the power producing or power absorbing. Just a minute, be online. Just a minute.
Yes, sir.
Sorry, I was on leave. I'm in home. So my son disturbed. I'm sorry for that. And somebody was asked regarding the power banks, right? They are neither power absorbing device or a power generating device or power consuming devices. Just they are a batteries. Means what they are going to do is they are going to save the electricity and discharge whenever it is required. Okay? They are not coming under any classification of the machines because they are not power consuming or power developing. Okay, just it is a storage device. Okay, next, and then any devices which takes input as an electricity and do the desired work, any work, do any desired work for you people, those things are considered as power consuming machines. And any devices which utilizes the various forms of energy, either it may be water, wind, or steam, gas, whatever. If that is converted to electrical energy, then those machines are called as power generating machines. Based on the input, if I give a chemical energy, we will call it as engine. If I give a wind, we are going to call that machine as windmill. If I give a steam, we'll call it as a steam turbine. If I supply the water, we'll call it as hydraulic turbine. Like that, depending upon the input source, we are going to name that what exactly the machine is, what exactly the power generating machine name is. Is it clear? Is it clear?
Yes, sir.
Okay. That I have discussed yesterday,
Sir.
and I have shared the video of the class in the Google Classroom. You can join for the Google Classroom so that you can download or you can see the videos. And these are all the different forms of energies we discussed. That is mechanical, electrical, chemical, heat, nuclear, sound. You can write down n number of forms of energies. Not only these. I limited only here. In the notes it is there. But here, as a presentation, I wanted you to tell the answer. So what I did, first I asked the different forms of energies for you only. You told more than this. I'm happy for that. But you did not told about sound in this. Okay? Then we went about what are the different sources of energies. Renewable and non-renewable. We went about renewable and non-renewable. We discussed about renewable and non-renewable. I got the good answers for renewable and non-renewable. What is the renewable? Can anyone refresh? Those who came, can anyone tell those who joined yesterday and today? What do you mean by renewable energy?
So it can be renewed.
It can be renewed. Very simple.
Energy which can be renewed or which can't be depleted.
Very good. Which can't be depleted. We are considered that as renewable energy. Can you name any one out of that?
Air,
Very good. Next.
water,
Water. Next. Major sources: sunlight.
sunlight. Yeah.
Sunlight. Yes. So all those things are come under the renewable source of energy, which do not deplete. This is very, very important word. Which do not deplete, we can consider as renewable. And non-renewable energies,
Which gets depleted.
which can be
Which can
depleted.
be
Very simple.
depleted.
Which is so opposite to this, which can be depleted. Can you name any example for that?
Petroleum.
Nuclear
Petroleum.
Petroleum fuels, fossil fuels, petroleum products,
Yes.
gases, all those things are considered as non-renewable, because if we use that abundantly, of course, presently they are available abundantly. If I use continuously, then what will happen? Definitely one or the other day, the resources will get depleted. So those resources are considered as non-renewable energy. So presently, most of the energy sectors, you take any sector, we are completely dependent on non-renewable energy only. That is the source of coal. We want huge amount of coal. We are going to burn the coal, can take that heat, whatever the heat generated by burning of the coal is taken to produce the steam from the water, and that steam is used to run the turbine, then that power is generated. So that power we are utilizing maximum around 70 to 80% of the energy which we are consuming, we are using. 70 to 80% of the electricity is from non-renewable source only, that is from the coal, which may get depleted within a short span, probably maximum by 2050. Now we are in 2020. Remember, by maximum, if we use within the same trend, then definitely maximum 2050 or 2060, the complete coal resource will get exhausted. Or you may say the fossil fuel resources will get exhausted. We don't want that. We want that fossil fuel resources to be there for longer duration. That is one drawback with the use of non-renewable continuously. And other drawback is with the use of non-renewable, a huge amount of emissions are producing. We are producing a huge amount of emissions. That may be in terms of carbon dioxide, nitrogen oxide, smoke, hydrogen, hydrocarbons, like that. Most of the emissions we are going to produce with the help of this, by the use of this non-renewable energy. Presently, it is already running, but government has taken the initiation in such a way that we have to reduce the non-renewable source and we have to rely more on renewable energy, because it is having two advantages. One is it will not deplete at all. The second advantage is we can be considered as zero emission source. There is no emission at all if I use a renewable energy. So those sources are called as renewable. And government is also initiating from past 10 years. Government is insisting for all to use the renewable source of energy, at least for a portion of electricity what you are going to consume in your home. A best example is, have you seen the present day's street lights? How they are?
Yes,
In
sir.
the smart cities,
Solar.
especially in the smart cities. Very good. Each and every pole of the street light will be having a lamp. That is true. Above that lamp, you can see a rectangular plate. If you stand below that electric pole and if you check out, you can see a rectangular plate above that electric lamp. What is that plate? That plate is nothing but a solar. Okay, that solar means that particular pole which is glowing a light will take the power from the solar only. Like that, solar panels has been arranged in most of the applications. So we are trying to extract more and more the solar energy. So that is an eco-friendly. We are not going to burn any fuel to produce electricity there. What we will do? Just we will place a solar panel and we are going to heat up that. The light which is passing from the solar panels will produce electricity, and that electricity will be used for glowing a lamp. So that is a process we have done. Can you name any other application of that solar where you have seen the solar panels placed? Any other place?
Water heater.
Spaceships.
Huh?
Spaceships.
Water
rockets.
heaters.
Water heaters. Usually, these solar panels are maximally promoted to use in the villages. Why? Because in villages there will be abundant space available. They can place the solar panels and the electricity can be generated, and the generated electricity can be used directly to the houses. Anyhow, in the villages the space will be more, and number of users in terms of houses in the entire village there may be of 200 or 500 houses. But if you come for the metropolitan cities, in one apartment only there will be 500 houses. So we cannot completely rely on the solar in the cities, but in the villages you can completely rely on the solar. So that government has given a plenty of opportunities to place a solar panels and use that and then produce electricity. That is one possible way of using. What is the advantage of using renewable? And one more advantage of using renewable one more application is the windmills. You can see if you go for Ballar, Chitradurga. Anyone visited Chitradurga who was over there in Karnataka? You can see a big fans around Chitradurga city, or you can see wherever the hilly station is there, you can see a big fans. Those fans are used for generating electricity, which is renewable.
Windmills, sir.
Yes, windmills. Windmills are used to generate the electricity, and the amount of electricity what they are producing is such a huge that they are selling to the government. Means excess amount they are producing and they are selling to the higher cost to the government. So such a way the improvement is already done in the place of windmills, but the places where they are installed is very less. Okay, that has to be expanded further. Like that, instead of completely relying on non-renewable source, let us try to move for renewable. Those things we'll study in this. What do you mean by renewable? What are the different sources? All those things. Then coming for conventional and non-conventional. Yesterday there was some confusion between your friends. What do you mean by conventional and non-conventional energy sources? Repeat again those concepts. So conventional sources of energies are those. Just one. There are so many definitions for that. Explaining the conventional source of energies, there are so many definitions. One small definitions we can put in such a way that if the energy is produced in the mass, then we can consider that as conventional source of energy. Or if there is no if the cost involved is more, we can call it as a conventional source of energy, like that. These are all the different definitions what you can tell. And the conventional source of energies are fossil fuel, hydro energy, nuclear fuels, natural gas, petroleum, coal. All these are considered as conventional source of energy. Okay. And non-conventional source of energies are which produces a small amount of power. That is less magnitude of power generation. They're considered as non-conventional source of energy. Okay, which is high demand and the low supply. That means there is a huge demand, but the supply from non-conventional source of energy is very less. Because solar, I cannot place the solar in all the places, or I cannot utilize the solar panel and during the night or rainy season. So that energy, high demand is there for supplying electricity. But from this solar, I cannot supply the complete energy. So that the supply from the solar panel or solar sources very less. Like that with the help of wind also. There is a high demand if I use a windmill and produce electricity. But that again depends upon the velocity of the wind or speed of the wind. So that the supply will be less. So wherever high demand is there and low supply is there, those type of energy sources are considered as non-conventional source of energies. Example, solar, wind, geothermal, tidal, and biogas. What do you mean by this geothermal? Anyone can tell? Geothermal. Any idea about geothermal? Yesterday, I guess Bhumika Bhatt has explained that. She has given an example of that geothermal.
Sir, which uses coal to produce electricity.
Which
uses a coal that will come here.
So it is the
that
heat.
Is fossil fuel.
So geothermal energy is the heat produced from the surface of the earth.
Now, how the heat is produced from the surface of the earth?
Underground.
Somebody was telling. What is that?
Underground heat will present now, sir.
Yeah. If you go deeper and deeper to the earth, and if you reach the crust of the earth, very good. There is 3 reasons. I think probably you know: crust, earth surface, crust, mantle, and core. If you go deeper and deeper into the earth, you can find out enormous amount of energy. That is heat, which is more than the heat which is there inside the sun, which you can find out on the sun surface. A huge amount of heat is there. That heat, if you could able to trap that heat or take that heat back and produce electricity, those type of electricities, those type of power plants are called as geothermal plants. But you cannot get that energy, to get the heat which is there underneath the earth surface is very, very difficult, because you have to drill a well to a huge depth. And in all the places, you cannot get the geothermal energy. Only at particular locations, you can get the geothermal energies in the form. Have you seen the hot springs anywhere or volcanoes appearing?
Recently.
Recently, I've seen that.
No, sir. In this year only.
In this year, you have, I think, probably you heard about volcanoes has appeared. I think in some particular places, always there you can find out the hot springs as well as the volcanoes which is appearing. What is the reason that hot springs are coming out or volcanoes are appearing? Can anyone? General question. These are all general.
Geothermal energy.
Yeah.
Geothermal energy present.
The excess amount of heat which is there underneath the surface of the earth or at the core of the earth will try to escape from that portion, and then it will try to come out from the earth surface. If it try to come out from the earth surface, you can find out the hot springs or volcanoes, which get mixes with the rocks. Then it will become a volcanoes. Very hot. It is nothing but a stone, right? Very hot stones which is coming out from the earth surface. If you could able to extract that heat, those kind of energies is called that method is called as extraction of the electricity with the help of geothermal energy. That concept is called as geothermal energy. And then tidal. What do you mean by this tidal energy?
Right.
This tidal energy, usually, I think probably you might have not seen, because this tidal energy we are going to extract at somewhere away from the surface of the earth. If you go for the ocean, at the center of the oceans or somewhat away from the Earth's surface, you can find out a huge tides. Those tides will be having energy, potential and kinetic energy, right? If the tides are rising, it will be having potential energy, and if it is falling down, it will be having that potential energy will convert it into kinetic energy. If you could able to extract that energy produced from the tides, we can generate electricity. So that kind of plant is called as tidal plants which produces electricity. But we cannot predict where the tides will be more, and magnitude of the tides will be more, where I can produce electricity more. I cannot predict. Even though it is producing, that is one of the concepts what it is designed or it is planned, but we don't know. We cannot predict where tides will come all over the day, right? So that we cannot generate the power which is as much required or as much demanded. So again, this will come in picture of non-conventional. And biogas. What do you mean by this biogas? Where you can find out this biogas energy? How the biogas energies or electricity from the biogas is produced?
Cow dung.
With the help of cow dung, kitchen waste, animal
Farm
waste, farm waste, kitchen waste, any waste. Especially you can see this biogas plants in villages, right? Because so much of cattle will be there. They will try to put that cow dung in some container which is
Biogas plant.
there in the ground, and they'll produce a biogas. Instead of producing electricity there, what they will do? The gas will be produced, and that gas directly they will connect to the kitchen stove, and then they will try to cook the food with the help of that biogas. So that is also called as non-conventional energy source. So these are all the things I can put under non-conventional energy source. So you can add up whichever you know. You can add up. Not only these are all called as non-conventional. You can add up any source of energies which produces in a less magnitude. You concentrate on this word. This is very important keyword. Any power source which produces any source of energy which produces only the power with a less magnitude are considered as non-conventional energy source. You can put that. You can find out which source is producing a small energy. You can put here. Okay. Shall I proceed?
Yes, sir.
Okay. Now we'll go for renewable source of energies. Renewable source of energies. As I discussed, what do you mean by renewable source? Which will not deplete at all. Which will not deplete at all. But this renewable source, of course, plenty of spaces we are available. I mean, solar is available all over the country. We will talk about only India. Everywhere in each and every corner of the country, we can find out the solar energy. Even though we cannot take the entire energy of the solar. What is the reason? Because what is the reason we cannot take up the solar energy completely? Huh? Rahul Singh, can you mute? Suhail? Rahul Singh and Suhail, please mute. Syed, you raised your hands. What is the reason? Sir, should we present it today or when you are doing the topics of the point? Okay. Bhumika Bhatt, what is, so when we should present the hydropower plants? Okay. See, before presenting the whatever the work I told, you please send that PPTs to me for my personal number, so that I'll check out what thing to be added and what thing to be deleted. I'll tell you so that you can present. I will tell when to present. Okay.
Sir, the PPT, sir, we actually you told about the templates yesterday, but we already completed the PPT like long back, like 5 days back.
Okay.
So should we'll add the template, we'll do it in the same template from next time, sir.
No, what you do is whatever the thing you have done, just copy. See, if you copy this entire thing will go off. No, you can remove and you can place it on that template.
Indentation and all full it'll get changed, sir.
Okay. If it is so, then no problem. If you are able to do, you try to put in the proper template. If not, let it be. No issue. We are worried about the contents.
Yes, I will share the PPT to your number.
Okay. You share the PPT to my number so that I'll tell you when to present.
Okay.
If you are ready to present, we can proceed tomorrow only. In the next class. No issue.
Yes.
Okay. See, the solar, even though there are so many sources of renewable, that is solar, wind, geothermal, tidal, hydro, bio, fuel cell, hydrogen, even though there are so many sources of energies, we could able to take out only 13% of our needs. Out of 100%, we could only take up 13% of our needs. Among so many, we are having almost 1, 2, 3, 4, 5, 6, 7, 8 sources of, I listed only few, that too 8 different sources I listed here. Out of these 8 sources, if I club together, I can extract only the power of 13% of our needs. Remaining 87% of the needs is satisfied with a non-renewable source only. That is, you can imagine how much we are relied on non-renewable source of energy. That is not required in future. In future, this percentage has to be increased. That means you have to extract more and more power either from solar, wind, geothermal, tidal, hydro, any one out of this, you have to extract more power. That is the intention. What is the reason? If I extract more power from these sources, what will happen? See here. Because if we extract whatever the amount of energy if we can extract from here, it will be continuously restored by the nature. So there is no term called exhausting. It will be continuously restored. There is no issue of depleting. So that I can extract more and more power from this. Then it is called as inexhaustible sources, or it is also called as non-depletable sources. And these are all major important things. This pollution. These are all pollution free. There is no emission coming out. If I use a solar, no emission, 0 emissions. If I use wind, 0 emission. Geothermal, 0 emission. Tidal, you can take any one out of this. The emissions will be very, very less, or you can consider it as zero emission or pollution free sources, and which are available in free of cost. Solar, I can easily free of cost. With the free of cost I'm getting. Wind also with the free of cost I'm getting. All these are produced from the nature. So that with the free of cost I can get the input source. So we have to work out on this, how to extract these energies and produce electricity. But what is the problem with this? Why, even though there are so many advantages, see, let us consider these are all advantages. Pollution is not there, free of cost, non-depletable, it is inexhaustible and restored by the nature. Even though there are so many advantages, what is the reason we are not used this solar, these sorts of energy till now? Because, see here, because of high initial cost. If you want to place a solar panel, all over the country, then it leads to a very, very huge cost. Because till now, imagine, you can tell India is completely, means all the countries have developed like anything in all the manners, like that you can tell. But one small corona told that we are not yet developed. Not only India, all over the world has not yet developed. And like that, you just imagine, only in the entire world, only 2 countries are capable enough to produce the solar panels. One is Japan and one is China. Other than these 2 countries, none of other countries have developed the solar panel yet in a complete efficient manner. Just imagine what is the technology involved to extract the solar energy. Only 2 countries knows that how to extract the solar energy, that too not completely 100%. Clear? So it requires higher initial cost. That means the materials what they are using there, it requires higher initial cost, but less maintenance. If I use that, of course, initial cost will be less, but there will be no maintenance at all. You just take an example of that pole. At the top, there will be a small rectangular shaped plate, which is having a solar panel. If we install that, it will be having, such a small plate itself will cost around 5,000 to 6,000. But once it is installed, there will be no maintenance at all. And not perfect technology to extract the energy. There is no perfect technology yet appeared to extract any of this energy. Okay? With complete utilization, there is no perfect technology. So we are lacking behind. So still we are in 13% of use. And can build near the load point. That means, what do you mean by this load point? I cannot take the windmill, I cannot take this and I cannot place in Bangalore. Because the speed of the wind is not sufficient to rotate the windmill. So what I should do, I should again take this windmill and go to a particular place where the wind speed is or wind velocity is 35 to 40 meters per second. Then only I can get a power generator. Similarly, I cannot create a geothermal plant in Bangalore or Karnataka because there is no hot springs here. Wherever the hot springs are there only you have to go and you have to place the geothermal energy. And tidal, I cannot place the turbine hydraulic turbine in Bangalore simply because there is no tides available. We have to go to the coastal regions. Then only I can get it. Like that. I have to build these sources only wherever there is a available sources. Because of that also we are lacking behind to produce electricity from these sources. Is it clear?
Yes, sir. Yes, sir.
So what is the output of this slide is the renewable energy sources are so many are there. You can name this all this, and out of those so many, if I club together, just we are producing 13% of our needs. What is the reason? Because of these reasons. Because of these reasons, we could not able to extract the power much. And there are some advantages for this, and there are some limitations. These are all advantages, and you can write this as limitation. Higher initial cost, no perfect technology, those things you can write it as limitations. Is it clear? Then I'll proceed for non-renewable. See, non-renewable sources, even though there are few sources, that is fossil, nuclear, coal, gas, and heat traps. So there are only 4 to 5, but they are satisfying 87% of our needs. What is the reason? Because occurs only one. What is the reason? Because already superior technology is developed to extract energy. To extract the energy for fossil fuel, a high technology is developed already, so that we can extract, we can place the fossil fuel plant wherever, and we can extract the electricity. Nuclear plants also. So like that, I can place and I can extract. And some technical feature for this occurs only once in nature. But that means they are exhaustible, or in another way, you can tell it as depletable, and they cause us an enormous amount of pollution. Enormous amounts of pollution they are producing. What are the pollutions they are producing? Contaminated gases, radioactive residues, greenhouse effects, global warming. These are all the effects of using non-renewable source of energies. Contaminated gases, radioactive residues, greenhouse effects, and global warming. These are all the major source of emissions which we are going to get from the use of non-renewable source of energy. And they are not free of cost. We have to take the coal, extract the coal. To remove the coal from the earth surface itself, it takes a lot of amount. Correct? So it involves more cost. Initial cost is less, but maintenance cost is more. That means this point I have taken in terms of the turbines. If the fossil fuel is burned and electricity is generating, the turbine plant will be having a less cost, but the maintenance will be huge cost. If any blades break down, or if the entire plant shut down, because of the maintenance, the cost will be more in that case. Because of that intention, I take this point. And superior technology is already developed to extract the energy. Because of that, we rely maximum on this non-renewable sources of energies. Is it clear?
Yes, sir.
See, these are all general terms, what we discussed, because you already know what you mean: renewable, non-renewable, conventional, non-conventional, what are the sources, advantages of those, limitations of those. You can write down beautifully. Whatever by the discussion, what we did now, you can write down in exam beautifully. Okay? Then we'll go for next topic in the syllabus, that is petroleum-based fuels, or they are also called as fossil fuels. Petroleum-based fuels or fossil fuels. So how these fossil fuels are formed? Can anyone tell? How these fossil fuels are formed? Rishabh?
They are decay of plants and dead plants and animals.
Didn't decade.
Yeah. How it is formed is thousands and thousands of years ago. If you go, the plants, animals, or any microorganisms, all those things which are decayed or buried inside the land, it undergoes a technical process. I'll tell what is the name of the process. It undergoes those processes, and then because of that, the decaying of all those things takes place. Plant, animal, ancient, microscopic plants, bacteria. You can name still more. I given only few. You can name few more. Okay, that lived in the ocean and salt water seas. So because of these decaying of these matters, the fossil fuels are formed. How they are formed? See here. These microorganisms died and settled to the sea floor They mixed with the sand, silt to form organic rich mud, which was gradually heated and compressed chemically, transforming into petroleum, oil, coal, and natural gas. So this is a very important word here. Gradually they get heated up, compressed. Okay. So whatever the plants, animals, as you told, all those things are buried inside or went inside the earth's surface over the long period of time, and it undergoes a huge, enormous amount of heat and also a pressure, a compression pressure. Because of all these, that is time, heat, and pressure. Because of these three, they are converted into petroleum, oil, coal, or natural gas sources. They are mainly called as fossil fuels or petroleum-based fuels. Okay. In that, what are all the different? Usually, fossil fuels will be having a higher percentage of carbon in them. Either you take anything, either it may be coal, petroleum products, oil, whatever you take, there will be highest percentage of carbon in it. Okay. The percentage of the carbon depends upon the available nature. If it is in soil, if it is a solid state, you'll be having different percentage of carbon. Liquid state, percentage of carbon will be different. Gaseous state, percentage of carbon will be different. So solid state fuels are called as coal, all kinds of solid fuels. Liquid fuels are called as petroleum oil, or you can call it as, usually you can call it as a crude oil. Liquid fuel means a crude oil. By the distillation process, we can get diesel, kerosene, gasoline, that is petrol. Like that, we are going to get different sources of, we are going to name different sources by the help of distillation process that you know. And gaseous fuel, all the natural gases we can obtain from, all these are considered as this petroleum based fuels or fossil fuels. So this is a table where you can easily understand what all the different sources of fuels are there. Sources of fuel, physical extents of how they are in the form of solid, they will be in the form of liquid, and they will be in the form of gaseous. Solid, liquid, and gas. In that, naturally, which are the solid sources available? Under the solid, if it is natural, wood is a natural solid source, peat is a natural solid source, coal is a natural solid source, lignite, bituminous, anthracite, all these are naturally available in the form of solid. So something we are going to produce, means we are going to manufacture based on our requirement, that is wood charcoal. It is not naturally available. We have to prepare that. I'll show you how they are prepared. Coke, briquetted coal, pulverized coal, all these are in the solid form, but not naturally available. It is created. They are created one. These are also solid fuel. These are also called as solid fuel. But these are created by the atmosphere or naturally created. And these are created artificially because of our application. But both are available in the form of solid state. Similarly, coming to the liquid, crude oil is in the form of liquid, which is a naturally available. If we do the distillation, I'll get petrol, I'll get kerosene, diesel, tar, alcohol. These are all created from the crude oil. Okay, both of them are in the form of liquid state. Gases, natural gases are available naturally, and from this we are going to get a coal gas, coke, oven gas, producer gas, water gas, gas, depending upon the application, how exactly we require, we are going to take out by the distillation process from these three sources. Any doubts in this?
No, sir.
Okay. Alternative for this sources, CNG, LPG, hydrogen gas, biofuels. This is the alternative sources for these natural resources or the natural fuels. What you can understand from this figure, can you tell? I will not discuss about the wood. Whether I should discuss where it is available, which form it will be, whether I should discuss?
No, sir.
And if I burn the wood, I'll get a heat. And from that heat, I can generate electricity.
At the end,
Coal, lignite.
Sir, may I talk, sir?
Huh?
Sir, in the end, after you finish, can you share the PPT, sir?
This PPT, yeah?
Yes, sir.
See, what I'll do is, whatever the PPT I'm presenting now, that PPT will be recorded in the Google Classroom. No, I mean, the PPT will be recorded.
Could you share the recording, sir?
Yeah, definitely. Every day I'm sharing the recording in the Google Classroom. Day
Okay,
wise,
sir.
I recorded. If you join for the Google Classroom, you'll come to know what all the videos I shared.
Yes, sir. I'll join. I've joined. I'll see, sir.
You see that date wise, I shared the videos of the class. You can open it. And somebody has asked yesterday that video is not opening. So usually it will be taking, there will be a processing time. I think probably half an hour.
Sir, I don't have the code of your classroom, sir.
Okay, I'll share the code of the classroom right now. After this class, at the end of the class, I'll
Yes,
share.
sir. Okay, sir.
Okay.
Okay.
It will take half an hour to 45 minutes to process and then to be played. So that wait after the class for 45 minutes, you can see the video.
Hmm.
Okay. See, these are all the wood. As I told, I'll not discuss much because you might have seen what will happen if I burn the wood. Anybody know about how the peat is formed, how the lignite is formed, bituminous is formed, anthracite coal is formed? Any idea? Anybody having any idea?
Sir, through plastic.
Sir, peat is formed by incomplete decomposition of the organic matter. Sir,
Hello?
Yes, sir.
Yeah, somebody was talking or somebody was asking something.
sir, I was telling about peat formation.
Very good. Tell me the peat formation, how it is going to form.
It is formed by incomplete decomposition of organic matter.
What's your name? Bhumika. Very good.
Yes.
See, usually incomplete of any manure, we can call it as incomplete manure or decaying incomplete, whatever the completely decay, those source we can call it as a peat. In other way, the manure which is having or a
Sir, you are not audible, sir.
I'm not audible.
Now you are audible, sir. Now.
Okay, okay. Because I'm in home, no, so there is no proper network here.
Yes, sir. Your voice
Can you
is
hear
not
me?
coming clearly.
Hello?
Yes, sir.
Hello?
Yes, sir.
Yes,
Can you
sir.
hear me now?
Yes, sir. Now you are audible. Yes, sir. Yes, sir. You are
You're audible now.
audible now.
Hello.
Sir, you're audible, sir.
Okay, okay, fine. See, in the figure you can see here, this coal, I can classify again coal as lignite, bituminous and anthracite. We have discussed about the peat. That is finished. Peat is finished here. Now we'll go for lignite, bituminous as coal. But the quality of the coal taken and the pressure, how much it is undergone, and the time and the heat, how much it is undergone. So the quality of the coal increases based on the higher the pressure, heat, and time. If it pressure, much heat, and much time, the source of coal which is available here is called as lignite, which is having lesser moisture compared to the peat, but higher bituminous. If still
Sir, your voice is not coming clearly, sir.
no.
Yes, sir.
Okay.
Yes, sir.
I'm extremely sorry. What you do is I think probably there is
Yes, sir.
no.
Now it is good. You are audible now.
Okay. So as the time proceeds, there is high pressure, and because of the high heat under the earth surface, the coal is formed. That is anthracite coal. So this lignite, bituminous, and anthracite, all these three are considered as a coal, but depending upon how much pressure it quality of the coal, temperature, and high larger time it has taken. That you can see in the figure. See, in the figure we can see lignite coal, where this is almost a coal. You can use it for the burning or application, but it will be having a moisture in it, and it will take. It will be having a. Huh?
So we
Sir, your
can't.
screen is off, sir. We
You can't see the
sir.
PPT. Yeah, just a minute. Just a minute. Sorry. Can you see now?
Yes, sir.
Okay. So this is lignite, bituminous, and anthracite. All these three are called as a coal based on how much pressure it has undergone.
Yes, sir. We can see now.
How much heat it has taken, how much time it has taken. We are going to classify it to three types. So you can see the figure of lignite. Figure A indicates the lignite coal, bituminous coal, and C indicates the anthracite coal. See the quality of the coal which has, all these are formed from the peat only. But this lignite has undergone much pressure, much less pressure, less temperature, and less time. So that we'll get this coal. It will be having a moisture in it, and then it cannot burn completely, and it looks like somewhat brown in color. Any coal which is in the brown in color, we can name easily, we can call it as bituminous coal, and it will be porous. It will be a little bit porous. Then that will be called as lignite coal. And bituminous will be having somewhat a shiny structure, shiny formation, and it will be not so much porous, and it will be somewhat black in color. So that we can easily tell it as bituminous coal. And anthracite, you can see a very fine shiny structure on that surface, means a shiny surface with a completely packed, there is no porous at all. And in the anthracite coal, the carbon content will be huge enough, and the calorific value will be huge. There is no moisture content at all, so that this is considered as highest quality of the fuel, highest quantity of the coal. All these are coal only, but lignite is less quality, bituminous is intermediate, and anthracite is a highest quality coal. By the appearance only you can identify. Lignite, which color it will be?
Brown.
Brown in color, porous in nature, and lower calorific value. That means lower heating value. Bituminous, little bit of shining,
Gray.
no,
Black.
little bit of shining, somewhat black in color, and then you can find non-porous structure. And if it is completely shining, completely packed, and completely non-porous, then it is considered as a good quality coal, which is used for power generating application, or where calorific value of the fuel is more important, we'll go for this type of coal. But the cost of this coal is very, very higher compared to these first two types, because it will go only, we can find out the anthracite coal only at the deeper of the earth. To take that coal, it will take huge amount. It will consume huge amount. Okay. And coming to the wood charcoal, that is, we are discussed completely about this: wood, peat, coal, lignite, bituminous, anthracite. In the next class, I'll go for artificial solid fuels. Artificial solid fuels. What is the application? What is the heating values and all? So this is wood charcoal, coke, briquette coal, pulverized coal. All these are the artificial one. But in exam, what to write? This is the thing what is expected in exam. We will discuss this in the next class. Is it clear? Along with advantages, limitations and all. Any doubts?
No, sir.
Okay.
No, sir.
So I will move
No.
a bit slow. I will move a bit slow with a proper discussion with you people and communication. Means interaction, proper interaction about the courses, about the topics in the first module. Because let others also join. Those who are joining from tomorrow or day after tomorrow, will wait for them. Till now, any issue for any students? Any doubts regarding the class? Okay.
No, sir.
Is it okay if I follow the same?
Sir, share the code of your classroom, sir.
I'll share. Very good. I'll share the code. Just a minute. I'll share the code of the classroom.
Yes, sir.
Any other requirement for you? Means whether I should move fast or let it be, or
Sir, books. Which book should we prefer, sir?
textbook is K.R. Gopal Krishna is too good book. K.R. Gopal Krishna is good book, or you can refer any textbook for EME. Just you go for the shop, ask them, give me EME textbook. All the textbooks are more or less the same contents. Or I will share the soft copy for you. You can refer the soft copy, same soft copy for preparation for the exam. That is enough.
Okay, sir.
Take the code. Can hello?
Yes, sir.
Can you see the code?
Yes, sir.
I
No,
shared the
sir.
screen. I not shared. Okay.
No, sir.
No, sir, we can't see, sir.
Now,
Yes, sir.
Yes,
Yes, sir.
sir.
Now you can see.
I'll share the code. This is the code for my Google Classroom. B3X70X.
Got it, sir. Thank you for the code.
Okay, fine.
Sir,
Given in the
copy
WhatsApp.
also, yes, sir.
Yeah.
Soft copy, sir. Afterwards, you share, sir.
Okay. I have given the class link under the description of your all the class, the theory classes from 8:30 to 4:30. There will be a single.
Sir, voice is not audible.
WhatsApp group. There you can get that. Okay.
Sir.
Is that okay?
Yes, sir.
Okay, fine. All of you, please type your USA number. Sorry. Type your name only once. Don't type twice. And you can leave the class. Thank you so much. If you're having any doubts, you can discuss. You can be in class, you can discuss, or you can call me personally.
Okay, sir.
Sir, where to get this book, sir? Sir, I don't have any idea to, sir, how to get this book, sir. Sir,
Textbooks or what?
am I audible, sir? Yeah, textbook.